We will create a simple motion detection system that will loop over a video and see if there is any movement, and it will also track that movement. The first thing we need for this particular project we would be openCV, which we would be doing by import CV2, and we can also have a video file that we are going to read and then use that video file to detect any kind of changes happening in it. So I'll call my video file video CV2 video capture, and if you're doing this on a webcam you can just simply put 0 over here, but if you want to read it from a video file then you can always give the file name. Now I have a file called test3.avi and I'll quickly play this file. So I have VLC opened up here. So we can see there is this simple file which shows a car moving in the frame, and our project should be able to track that particular car moving in the video frame. So let's see how we can go back. So going back to the code, so we have now created that loop, created that video capture where it will read the video file coming out, and let's open up a while loop and we'll call it while true, so which will run infinitely, or you can put down while until the video file is played. So the first thing we'll do is we'll make a status file, status frame equal to video.read. So we are just reading the video, each frame coming out of the video, and then storing it into this variable called frame. The status tag over here is nothing but a boolean flag which let us know that whether the frame was read properly or not. So if you can just simply put down, if you say print status, it will give you the result equal to true or false. So it's designed to do either true or false. I'll just delete this off, and if it's true then it means that the frame was read properly. If it's false then the frame was not read properly. So coming back to this, so you have read the frame. The first thing you want to do is change the color profile from colored to gray. So you will say gray, which is grayscale right now, and you will use openCV's convert color frame, because all the processing that we are going to do right now, it's going to happen at the grayscale level. So we want all the images, everything that we use in grayscale. So we'll use convert color CV2 color BGR gray. So we are converting a BGR format to grayscale format. Now we are also going to blur this a little bit so that we can remove the unnecessary noise that will be present in the video. So let's see how that comes out. Gaussian blur, and we'll do the blurring on the grayscale. We'll give a filter size of 21 by 21 -0. So that will create our blurred image. So let's see how this looks. We'll create a show function, CV2im show, and we'll crawl grayscale, gray image or gray video. We'll call gray video and we'll call this as gray function. So let's save this, and let's not forget to have our wait key function, without which this will not work. So we will call the wait key function as key equal to CV2 wait key 1, and if key equal to Q, which means that I'm trying to press the button Q. So if the button that we pressed was Q, then it should come out of the loop. So we'll simply call break. We also want to, once everything is done, we also want to release the video capture that we did. So we come back here and we'll say video dot release, and also we want to let openCV know to destroy all the windows that it had created, because it'll be creating this grayscale window, the gray video. So we want to let openCV know to destroy that video as well, because we don't need that once the program is done. So that's about it. We're just going to simply open the grayscale video and see whether the test.avi file was read properly or not. So let's save and let's open up our command prompt. I have the command prompt here, and we just run Python let me see what was the file name. We gave the file name as motion underscore detection.py. So we call it as motion underscore detection.py, and we will run this. So it looks like there is an error. We put just one equal to sign over there. We definitely need two equal to signs right here, and we'll save this back again. Let's open up our command prompt. Let me clear this and we run this. So we can see that it's playing the video and it's kind of a blurry image because of the Gaussian blur, and the grayscale function is working properly. Let's come back and continue with our program. So once we have the grayscale video, we can now use it for our processing. So the first thing you want to do is understand how motion detection happens. When do you see a motion has happened? Only when and if you see there was a change in the image. Say for example, if we come back to our image and we see the motion that is happening, it's a car that is moving. Initially the car was not present over here, so the image did not have any object in it. So like for example, in this case, if you say there's no motion on this side of the street because there is no car coming in or no object going through. But in this particular case, in this particular region of the image, there is some motion because the car is moving. So what is that motion? How do you say that there is a motion? Because there is a new object present in the image. And how would you define that object? If someone would know what the background looked like or how the street looked like without the car, and then see the new street which has cars in it, then you can say, oh, there is some kind of a motion, there is some difference, and of course that's the motion that happened. So that is exactly what we want to do. We want to compare our background image with our new image that is coming through, and if there is any considerable difference, then we can tell, yes, there has been a motion and it is worth detecting. So for example, we'll just go ahead and play. The car has moved from this region to this region, and we can see that the motion is happening because the original background image is now being replaced by this object, and of course it has now changed. So in order for us to do that, we would need a simple image with a background. So like for example, before the car came in, if we think about it, just before the car came in, there is a portion of the image which does not have the car in it. So we need that image which does not have a car in it. So I have this image saved here, so let me open up that. So we can see that this is an image that I have here, and you can see there's no car present in the image. It's just a shadow of the tree and no car present. So this is nothing but the background image, and we need this image for comparison purpose, because any image coming from the video frame is now going to be compared with this background image to see whether a car was present inside the image or not. So let's go back to the screen and let's read that background image, because we need that background. So coming back here, once the video capture is done, we'll put the background image over here, and we'll say the background is going to be now used for detecting. So background equal to cv2 imread, and we'll call it background the name of the image that I have over here, I believe it's background2.png. So we can see, yes, it's background2.png, and we'll use this image for our function. We'll call background2.png, and we'll read this and we'll save it into this folder called background. And coming back here, we'll also, since we did the same thing over here, we converted the color profile from BGR to gray, and also we made the Gaussian blur. So we want to do that with this image as well. So let's call background equal to CV2 convert color, because we need to convert, because when we are comparing, we want both the images to be of the same size, same shape, same color, same, everything should be same, and then only you can make a perfect comparison. So background and CV2, oops, we don't need the inverted commas. Coming back here, CV2 color BGR to gray. So we have done the grayscale conversion. Now we also need to do the Gaussian blur. The Gaussian blur comes through background, again the 21 by 21. Everything should be same. So done. So now we have the background image. So we have the background image, and we have the new image which is coming out from the grayscale. So let's now see the difference between these two, and how we can find out the difference. We find out the difference by simply subtracting that. So the difference equal to CV2 absolute difference. Now openCV has this function called as absolute difference, and what you're doing in here is you're just subtracting. You're going to be subtracting two images, but you're going to be using the absolute difference between both these images. So we'll call background, and we'll call the grayscale image from here gray. Done. So it will subtract these two images, the background image and new images that are coming out of the video, and it will save the difference in this difference folder. And whatever now this difference image, we would need to display that difference image so we can see how the frame is coming out to look like. So let's see how this comes up. Let's use the CV2 IM show difference image or diff video, and we'll call diff. And let's comment this line so we don't open up simple images, and we can see the difference video over here. So let's come back to our command prompt and let's run this and see how it comes out to be. So we can definitely see some sort of a difference in this image. This is barely able to show us how that camera or how the car is moving. So I think we are pretty close to where we want. Now the next thing we want to do is remove that extra noise that we see, and the way we can see, we can remove the noise. And let me show the noise, what noise I'm referring to. So if you come back to the main video, you can see there is a lot of noise here in these regions of the image, because we are just interested in the car, but it shows us many other portions of the image. And in order for us to remove that noise, we would need to threshold it so that it can eradicate all the other noises. So we can call threshold equal to CV2 threshold. There's a threshold function in openCV, and you're going to be using the threshold on the difference image, diff image. The size is 30, because any difference which is more than 30, and that's the threshold value, any difference that is more than 30 would be then converted into a wide scale image. So we'll put down 255 CV2 thresh binary, and we're using a binary threshold function over here. So as simple as that. And we come back. We also do CV2 dilate thresh and the number of iterations equal to 2. So we are dilating the threshold image so that it removes the unnecessary noise from the image. We may or we may not need it. It's not very important, but let's see how that threshold image looks like. So if we come back here and if we say, okay, CV2 IM show threshold video, and we ask the threshold video to be displayed, and let's comment this one out and see how this works. Let's save this. Let's go back to our command prompt and see if it works. So we did not provide the argument for the source image because here we missed the argument of 1, and that is something we need to specify because what type of threshold you're working with. So let's come back and see how this works. So we can see now the most of the noise is removed, and we can now take care of the rest of the noises that we see. So come back here and we have this. So now we can see that there is a car moving and we have eradicated all the unnecessary noise. So let's see how we can remove those noise and all, just concentrate on that moving object, which is the car in our case, and we can do that by using contours. So let's take care of all the contours. So contours equal to, I think there's a flag in contours also. We will call it as, we won't call anything over here, or we can say result, res for result, and we'll say CV2 find contours in the thresh image, but of course we want to use a copy because we don't want to spoil that, and CV2 RATR external. This is just specifying some of the flags in the contours image, and CV2 approximate simple. So this is now going to retain all the contours that we see. And now let's draw those contours. So for contours, or for contour in contours, or CNTS, like we used on the top, we are now going to draw all the contours. X, Y, W, H equal to CV2 bounding rect contour. So what this is going to do is, this function is used to define a rectangle, a new rectangle out of the contour. So it's going to take all the information that is available in this contour and draw a rectangle out of it. And this rectangle is going to specify where your particular contour is. So let's see how that comes out to be, and we can simply draw it on the contour. And when we have this information X, W, Y, H, we can now draw a rectangle on the contour. And how we do that is by using the rectangle function of openCV and CV2 rectangle, and we can draw the rectangle on the main colored image, which is the frame over here. So we'll draw the rectangle on the frame, and we'll use the initial coordinates as X and Y, and we'll use the final coordinates, which is the bottom right coordinate of the rectangle, as x plus w, y plus h, and the color will give it as 0 to 55, 0, and then the thickness of the rectangle will give it as 3, and done. So let's see how this one comes out to be. We'll just simply show the image, CV2 frame all contours, and we'll just simply display the frame. So let's save this. Let's go back to our command prompt and run this. Oh, I think I did not uncomment this line. So let me comment the threshold so we don't get confused with all the windows that we have opened up. So coming back to this, we can see so many green boxes popping up here and there. So there is so much of noise present in the video, and of course it's taking care of all the images. Let me open that again so it's visible. So we can see that it's detecting a rectangle over here, a couple of rectangles on the leaves that are moving. We're not interested in those because those motions mean nothing for us. So we definitely are interested only in that contour which is big enough. So we can simply put down a function over here that only if the contour size is greater than a certain value, only then you would do this. So if CV2 contour area, and we will say contour is greater than or less than, say if let's say if the contour area is less than 100,000, okay, or 10,000. Let's do 10,000, and if it is less than 10,000, then continue. Okay. So we'll save this. And we will simply now go ahead and display all the contours that were available on except the noisiest contours. And let's come back to our command prompt and let's open this up. So we can see now all those experimental noises that were available here with the leaves and all are now gone, and it's only tracking the car that is coming through. So let me open that again. We can see that it's tracking the car with the shadow. That's the reason the box is that big. And it's coming back, and it's tracking the whole image. So that's how a motion detection our project is done. It's very simple and very easy to implement, and we covered quite a bit of important functions, especially converting the color, the Gaussian blur, the subtraction of images, the background subtraction, and then identifying the differences, and then using the threshold to only emphasize on those differences that are important. And of course, then once the differences are found out, you draw contours. Once the contours are driven, you're not interested in all the contours, but only in those contours that are important, that have essential information, which represent a body, a mass, a big body that is moving in the image. So with that, we come to the conclusion of this project.